Lecture 6, Digital Image Processing, EC703A. Sangita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narulan Institute of Technology. Content: Transform of digital images, inverse first Fourier transform. This is a picture, lot of information are there and we can find this information by clicking the image. But if I want to describe this, huge amount of words are required or may not be sufficient. Inverse first Fourier transform. The FFT is a first algorithm for computing the DFT. If we take 2-point DFT and 4-point DFT and generalize them to 8, 16 and onwards, we get the FFT algorithm. To compute the DFT of an n-point sequence using equation, will take O(n) square multiples and adds. The FFT algorithm computes the DFT using O(n) log n multiples and adds. The FFT is simply an algorithm that is to a particular method of performing a series of computations that can compute the discrete Fourier transform much more rapidly than other available algorithms. Cooley and Touquet has independently reinvented the work of Gauche, who spanned between 1777 to 1855, and James William Cooley and Touquet jointly reinvented this independently. So that indicates the work has started very earlier, but it has re-established to us recently. Now this shows a comparative study of how this FFT works and how it is better than that of DFT. N is the number of elements or variables that is working with this processing. If it is n number of variables at hand, then for DFT number of computational steps is n square, whereas the method of Cooley and Touquet of FFT algorithm, it requires n by 2 log n, that is to 4. For n is equal to 4, 2 square, for DFT it requires 16, whereas for FFT it requires 4. If n is equal to 16, that is to 2 to the power 4, for DFT it requires 256, whereas for FFT it requires 32. In this way, if we increase number of elements to 2 to the power 12, that is to 4096, for DFT it requires 16777 number of computational steps, whereas, or you can say memory, whereas for Cooley and Touquet FFT algorithm it requires 24576, almost 10 to the power 3 times faster than that of the FFT. It is a simple calculation. So as the number of elements is huge, we have to proceed for FFT. There is no other alternative. Now comparison of efficiency of various FFT packages. Perform forward FFT of 2048 real random numbers and repeat 1000 times test environment operating system Windows 7 64-bit CPU Intel i5 752.66 GHz compiler GNU G Fortran. Discrete summation CPU time is 711.8014 seconds. Discrete summation storage trigonometric term 67.8448 seconds. FFT numerical recipes 3.712428. NCAR FFT packs 0.3276 and FFTW 3.3 0.0624. This shows as we go from DFT to FFT how much time saving is there in terms of computation. Now here is an example of how FFT from time domain to frequency domain and vice versa is working, and below towards the equation from time domain to frequency domain and from frequency domain to time domain. When a time domain signal in the right hand side is transformed to frequency domain, we have to apply DFT or FFT. From where, if we want to go back from frequency domain to time domain again, we have to apply inverse first Fourier transform or IFFT. There is a MATLAB Simulink over there, how it works. Here is a signal, sine wave, then it is passing through summation matrix, then it is converted to with the help into frequency domain with the help of FFT, then IFFT again to transform back to time domain, then it is finding through scope. And if we find this through scope, if there is no transfer in between any operation other than FFT and IFFT, then the same signal we can find through this time scope. Now this is a big O complexity, how it is working and how it is working. So in the x-axis it is the number of elements and in the y-axis this is the operation. So we are only concerning about O(n) square and n log n, that is to the purple line and the blue line. So it is fine, it is quite clear, up to 20 n squared is working, or up to 30 number of elements. After that it cannot work. Whereas n log n can work up to 100 elements or more, and it is almost linear. So up to 30, how it is works? When the number of element is say 30, corresponding operations here showing almost 150, approximately, not exactly I am saying 150. Whereas in the same case for n squared, it is more than thousands operation. So it is quite clear that FFT is faster than that of DFT. Now this is another Simulink operation, how it is working. This is a signal xn, it is a transform function hk, and it is FFT, and it is going to hk, and it is xn. They are multiplied. Then after multiplication, the function become yn, discrete. Then inverse Fourier, first Fourier transform, it is operated. So final signal is looking like this, yn. It is an example. This is the references. And thank you. This is all about the day. Bye bye. We will meet again.